The next section of the project involved connecting the FSM to the program counter here, as you can see, and then having the program counter connect to our memory. To create the memory at first, I thought that we would use the program counter and send these 4 inputs to a decoder that would give you 16 outputs corresponding to each line of the memory. But then I found that with the built-in read-only memory function here, that if I plugged in a 4-bit address, that would correspond to 16 lines. Therefore, when I give the read-only memory 4 inputs, as I increment the inputs, the ROM will move values. And I had trouble at first figuring out how exactly to plug in the corresponding data that I wanted. But ultimately I found that each 8 bits was going to be represented here in hexadecimal form. So I converted the first 4 binary numbers that I have here from binary to decimal for the first one, and then binary to decimal to get the hexadecimal conversion. And I did that for all the corresponding values and plugged them in. I chose these based off, I think the first 3 were from the slides, but I chose these so that all the instruction registers were covered, and then I just duplicated them for the last 8 rows. So that's that. And then the next step in the process was so now that, as we can see, our FSM is able to select the different bits, the different lines of data that we want. As we can see here, moved values changed here. So now we needed to basically find a way so that when the load instruction register was high at 1, the outputs of the memory would be loaded into their respective locations. The instruction registers here would go back to the FSM because they are inputs of the FSM. So we can see here, input register 4, input register 3 correspond to these values down here. And then the instruction register also would have to send the 4 data values into the bus when output instruction register was high. And for that, we want to use a tri-state buffer here. The tri-state buffer allows us to read the 4 bits into the bus when the instruction register is active, enabled. I think here I had found that I had actually accidentally put in a inverted tri-state buffer. So if we move down, left side here. Maybe not. It was. Yeah, it changed all the way. I realized that they had been inverted. Changed to a tri-state buffer here. The tri-state buffer is useful because instead of just a gate, the gate would have to read something out, either zeros or either a low or a high output. But with the tri-state buffer, we can actually write multiple things into the bus, because one tri-state buffer, well, when it's enabled, it will allow the data to be written into the bus. When it's not enabled, it won't output anything into the bus due to high impedance. Yeah. So that would be the FSM, the program counter, the memory program, and the instruction register.